Interesting video, Cosmic Zen. I mean, I tend to agree with your sentiments, but so my replies can tend to be um, tangential, or nitpicky on some particular issue. Um, I believe that time slows down when you go into a gravitational well, but the time differential in atomic clocks and experience in experiments is not due to the gravitational well effects. It's due to the velocity, the relative velocity. And which of the two clocks runs slower in the end depends, in general relativity, on which of the two accelerates itself into the other of the two's uh, rest frame. So the clock in in space actually will have looked to run slower because it was the thing that was landed back down on the Earth, synchronized into the frame of reference of the, or resynchronized into the frame of reference of the, of the Earth-based clock. If the Earth-based clock had been accelerated into outer space, it would be the one that ended up running slower. That's sort of the weird thing. It's like if two bodies are moving away from each other at half the speed of light, each one of them sees the other as having a slow clock. And whichever one turns around and goes back and meets the other, that's the one that'll turn out to have had a slow clock in the end when you have to correlate the realities when those reference frames come together. So yeah, I think it's really dangerous to relate the concept of time at all to our trip around the sun or our daily rotations. Um, Time is more like Einstein's ideal clock of a photon bouncing back and forth between two mirrors, or something more practical to actually construct, like you know the uh, the frequency of oscillation of a quartz crystal or something. So it's not really having much to do with the centers of gravity in that way. Though it is true that the closer you get, time slows down, and I think it's true what you said was very interesting about black holes maybe being where the end of the universe is taking place, because this is sort of true. If something falls into a black hole right at the event horizon, time stops. So if you were to fall into a black hole, you'd fall in and it might seem like it took 10 minutes or something to you, but to everybody else watching you, they'd see you falling in and you just slow down and slow down and slow down as you fell in. And you'd never actually reach the event horizon. They would see you destroyed because tidal forces would, destroy your ship at some point prior to hitting the event horizon. But it would take a lot longer for everybody outside than for the people inside whose time had slipped. Um, Relative to the people out. So, okay, anyway, just some 2 cents of feedback.